Okay. Good afternoon, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be presenting this afternoon will be the procedure on how to charge the battery of my cordless screwdriver. Okay. The voltage rating of this one is 12 volts. 12 volts. So meaning to say, if the voltage of this one drops below 12 volts, it's hard to operate this drill here or screwdriver. So what I did, guys, is that I use my variable power supply. That's my variable power supply. And the needed voltage to charge this battery is actually 12 volts. So I set the voltage of this one to at least a voltage greater than the voltage of the battery, 12.5. Okay. So this 12.5 could drive current to this 12 volt battery here. So as of now, I am now charging this one. This is actually my cordless screwdriver or drill. I could not operate this one for a good reason because the voltage is less than 12 volts already. So like what I said, I use my variable power supply. I set it to 12.5 because the voltage requirement of this one is 12 volts for it to be charged. And I also monitor the current drawn from the charger going to the battery. And as of now, the current DC is actually 0.802 ampere. The input voltage is 12.6, meaning to say if we try to measure the voltage across this red line here and this black line here, it's 12.6. So actually it could really drive a current going to this battery for it to be charged. So as of now, the charging operation is very good, and actually the current consumption is 0.835 amperes. The good question about this one is how do we know if this battery is already fully charged? If this battery is already fully charged, okay, we will try to take note of the current reading, because as the battery charges, this charging current should go down, okay? Meaning to say, if this will now drop to 0 ampere, we could say that this battery is already fully charged. So without even the indicator, the green light or the red light for a battery charger, for me as an unexperienced electronic enthusiast and an engineer, okay, I could determine if this battery is already fully charged by just looking at the current reading of the charging current. And like what I said, if this current now drops to 0, okay, the battery already stops absorbing current, meaning to say it's already fully charged. So that's the time that we should stop charging this battery here. So for as long as this ammeter here is here, and I could see it that it is not yet 0, I will still try to continue to charge this one. Then there come a time that this will be 0, and that's the time that I will stop charging this battery. So this is the battery of my cordless drill or screwdriver. As of now, I could not operate this one any good condition, good rotation, because the battery is actually less than 12 volts. And that's it, guys. So that's the importance of this variable DC power supply. Okay. I could use this one to charge a 12 volt battery a 9-volt battery or a 1.5-volt battery by just what you call this, increasing or decreasing to the desired charging voltage. And since the voltage I am charging or the battery I am charging is actually 12 volts, like what I said, I set this one to a voltage greater than 12 volts. So it could drive current to the battery. And like what I said, the charging current is a 0.893 amperes. Okay? That's it, guys. That's the way on how to charge a battery by using a variable DC power supply in which there is a current indicator here. Okay? Or voltage indicator, so I know what voltage I am injecting on the battery I am charging. And one thing more, I could also, what you call this, monitor the current consumption of this battery as it charges. Because I put in series with the black line here, an ammeter on the DC thing, DC voltage. Yeah, DC voltage. DC current. It is 0.898 amperes. Oh, that's it, guys. Good afternoon from Los Angeles. This is Professor David J.